Yeah, what's up? Explain the extreme value theorem is just overall maxes and mins. You could start at the highest point. You can end at the highest point. You could start at the lowest point. You can end at the lowest point. Why does it care about the endpoints on a closed interval? An endpoint might be a max or min. Okay, that's why. Do we always need to check endpoints to find extreme values? No, we don't. If your derivative is negative than positive, you know that this time must be a min. Your position at, I don't know, I'll call it A, you know, your position at A must be the min. Do you have to worry about checking endpoints? No. Sure. There's no possibility that the position at 0 or at B is the min because your position decreases and increases. So, no. Sometimes you just have a definitive answer. And then we just kind of combine our day 1, day 2, and day 3 stuff. Day 1, you have the position function, or you have the ability to have the position function. You are able to have exact positions. Okay. Cool. Day 2, you day 3, you have a velocity function, and you're not able to find the position function because you don't have information to find it, but it's okay. You can still take the antiderivative and understand that your position something with like a C, and you could subtract to figure out your displacements. Boom. You essentially know how far you've traveled. You do know how far you traveled. And then also day 2 was like using a calculator. So all that good stuff. Um, if you want to analyze when something is furthest right, you're talking about the max of position. When you're finding the max or min of something, you look at its derivative. If this is my position, I will analyze its derivative. I will figure out when it's 0. Why am I looking from 1 to 4? Okay, fine. All this is good. My position is decreasing. If your position decreases, where is your max? You know for a fact your position at time 1 must be your max. We'd have to talk about it. We'd have to explain why it's my max. You could find the position 2 minus 1 plus 2, so that's 3. But like I guarantee you, if I plug in 4, I'm going to get a lesser value. I get 8 minus 16 plus 2, so that's negative 8 plus 2, which is negative 6. Yeah, this is the max position because my position decreases. When do you want to find a max or a min of something? You look not at it, but at its derivative. Cool, I got plus or minus 2. I'm talking about 0 to 3. I have my derivative is negative. If I plug in 2.5 or 3, I'd get a positive. My derivative therefore decreases then increases. My position decreases and increases. My derivative is negative then positive. Here are my positions. When am I furthest right? Okay, well now we know it's not at 2. We know it could be at 0 at 3. Why is it not at 2? Because my position decreases and increases. Furthest right is the max. The max must be either at 0 or 3. Now I actually do have to check because I don't know for a fact whether it's going to be at 0 or at 3. 27 minus 36. It ends up being at 3. No, sorry, it's at 0. My position at time 0, which equals 0, wins. My position decreases from 0 to 2 and then increases from 2 to 3. I decrease to a position of 8 minus 24, which is negative 16. So you can kind of also look at your displacements if you want to, from 0 to negative 16, from negative 16 to negative 9. You can see I started somewhere. I decreased 16, increased only 7, decreased 16, increased only 7. Boom. Cool. Now, this is like day 3. You're given the velocity. You are unable to find the position.
But think about it, 12:30 and 12:40 could sound. But I did not say 12:40.
We have our derivative. We set it equal to 0. That's great. Oops. Cool. We find our times. Great. We do our sign analysis of our derivative. We got negatives, positives. We're starting at 0. We're going to 5. Furthest left, well, my position is increasing then decreasing. Furthest left must either be 0 or 5. Now, the only way to determine what it is to take the antiderivative. Not necessarily to get the actual positions, but we don't really need them. I got 6t squared minus t cubed plus c. My position at time 0 is c. My position at time 5 is 25 times 6, which is 150, minus 125 plus c, which is big, but we can do it. So 25 plus. Cool. You could say that your furthest left is either 0 or 5. You could say that your displacement, or the integral from 0 to 5, v is equal to positive 25, which means you ended up 25 to the right of where you started. Therefore, P of 0 is the winner. First left, it's got to be a 3. Wow. We're going to have to work on justifications. I don't want to get into it right now. Let's just get the right answer. But you'd have to say that P prime is negative from 0 to 3, and then P prime is positive from 3 to 5. As your justification, you have to be like, yeah, that's my only candidate. This covers all my intervals. Boom, I'm good. This one, your justification is that P of 0 and P of 5 are our candidates for the furthest left, since P prime is positive from 0 to 4, and P prime is negative from 4 to 5. So our candidates are at 0 and 5. Then you can just talk about how your displacement from 0 to 5 is positive 25. Therefore, P of 0 is less than P of 5, and it's the winner. You know, something like that. We'll try to be as formulaic as possible. All right, furthest right. Oh, cool. Why don't we do this, guys? It's a good question. Doesn't look like it, but it is. My derivative is positive. I wouldn't give you this question. This is like an unintentional mistake. I'm using the quadratic formula to be like the opposite of b plus or minus the square root of b squared minus 4ac, which is that all over 2a. And that's a negative value, which means I'm taking the square root of a negative, which means there's no real solutions, which means this is positive, which means my position's increasing. What am I furthest right? It's got to be at 4. Why? Because my derivative is positive from 0 to 4. What is the position? I don't know. It just asked me when. I don't know where. If you wanted to find where, you could, but you couldn't exactly know exactly where. You know, you would be this far from where you started. If you started at C, you'd be this far from where you started. And that's very important to know. So we might as well do it. We got one. Oh, I don't want to do this anyways. 2t squared plus 8t plus c. So where do I start? I don't exactly know where I started, but I know I ended this far away from where I started. 64 thirds minus 32 plus 32 plus c. Okay, there you go. I ended 64 thirds away from where I started. My displacement was 64 thirds. Therefore, my winner is P of 4. Cool. I feel like I did this problem. All right. It's either 0 or 5. It's not 4. That's a min. I'm furthest right. I'm trying to find the max position. Okay. Got to take the antiderivative. Again, this is my derivative. Velocity is just a fancy word for the derivative of position, the rate of change of position. So my position is t cubed minus 4t squared. Ew, 6t squared plus c. My bad. My position at 0 is somewhere. My position at 5 is 125 minus 6 times 150 plus c. That's gross. I'm sorry for this. 6t squared. My position at time 0 is c. My position at time 5 is 125 minus 150 plus c. It's minus 125 plus c. So where am I furthest right? At the start. My winner. Where's your location? Don't know. But I know I end 25 to the left of where I started. So you'd say that your candidate is not T of 4 because my derivative is negative to positive. And then you'd say that my displacement from 0 to 5 is negative 25. That would be my change in my position overall from here to here. Therefore, P of 0 must be when I'm furthest right. Great. All right, furthest left, we're talking about a min of position, or where and when. Our answers are P of a number equals a number, not just where. I'm trying to find the min of position. I'm given the derivative of position. We're going to have to break out Desmos and do a lot of fancy work with it. All right, so I got V of t equals t to the 2/3 cosine t plus 2. I'm looking 0 to 8. Oh, what? I'm hoping that is great. I have 2 sign changes, which sucks. Sorry for saying that, but it does suck. I have multiple candidates, okay? I got this value here, this value here. I would advise you, because you're not very good at what you're doing right now, And even I will lose track of things if I don't do this. To break out your friend Mr. Sign analysis, just write down what you see. P prime is negative until A. It is positive until B. It's negative after that from 0 to 8. Double check. Okay, we are negative values until A. We are then positive values until B. We are then negative values until 8. You can kind of see the displacements grow. Like this area is less than this area. So I'm going to go to the left a little bit. I'm going to go to the right more. I'm probably going to go to the left more than that, but I have to check. All right, I know my position at time 0 is 3. Trying to find a min. Now, you'll have to state this, but you don't need to check B. You know for a fact that you don't need to check B because it's a max. You know you're going to go up to get to the position at time B. You're going to go down to get your position at time 8. You don't have to check B. You don't have to check 0 because you go down to get to your position at A. Your only candidates are at A and at 8. However, for justification, you have to state why your candidates are just at A and 8, and you're going to have to find those. Now, this is when we need to integrate. So break out our integral, 0 to A of V of t. And this is how much I decrease. I will understand that my position decreases. If I accumulated my position from 0 to A, I get minus 2.077. That's how much I decrease. And I will take my 3 and I will add that to figure out P of A. One candidate is 0.922. You have to actually write this down on a test to get credit. I know you guys will believe that. Now, you could continue to do analysis of your displacements, go from A to B to figure out that you go up 5.29. You go from B to 8 to figure out, okay, so I go left 2, I go right 5, I then go left 5.7, or you could just go from 0 to 8. You have your initial position 3. You can figure out your overall displacement. Overall, from 0 to 8, you go to the left 2, which means it's going to be very close. Your position is 0.453. That's great. This position and this position, very close, but the winner is actually this position. P of 8 is the lesser of my two candidates. I did not have to look at every value, but if I did, great. But there's ways to find P of 8. You could have done 3 plus 0 to A. Then you could have also then figured out where you are at B. If you add the integral from A to B. And then B to 8. It's all very quick to do this with Desmos. It's like so nice. 0.453. So nice to do this in Desmos. Like, I hope you guys can like really explore and make sure you understand what these values mean. I can quickly just get rid of this and go from A to B of V of t. Understand how much my position increases, and then B to 8. All this stuff is just nice. And then everything should make sense. All the calculations that you're doing should make sense. You start at a position of 3. You subtract 2, you add 5.2, you subtract 5.7. This is the winner. Cool? All right. Let's look at the next one. 20. Negative 20 e to the negative t sine t. Oh, yeah. And I know my position at time 4 is 3. Look at that. Okay, cool. So this is my derivative. And I need this value here. Oh, it's just at pi. Okay, cool. It's a. So that's nice. You instead of writing a, and I should have wrote what a was equal to. Make sure you write what a is equal to on your test and on your quiz. Make sure you write what b is equal to if you're going to use it. Make sure you write your integrals for your test. We're just kind of making sure we're okay. 3 free response questions on your test. Okay, so my derivative, which is given to me, is negative until pi, and then positive from pi to 4. My position decreases, then increases. When is going to be my min? I know my min has to be p of pi. I don't have to check at 0 because my position decreases to get to pi, and then my position increases. It's the min position. So this is it. Now, I have my ending position at time 4. You need to find your accumulation from pi, or a, to 4. Okay, what does this mean? Your position increases 0.173. It increases 0.173 to get to the position of 3 at time 4. What do I have to do? Subtract that. Now you gotta show it with the correct work. I would say P of 4, or I would say 3 minus the integral from pi to 4 of v of t dt. And that is that 2.82. Everything should make sense. P of pi is 2.82. You need 3 decimal places, 826. So this is where I was at pi. I then increase this much, and I get to 3. Okay? All right. We're on the y-axis. No big deal. Highest point. I mean, like, it's actually easier to understand. This is a max position. I honestly might want to skip these problems. Let's just do it quickly. Just provide the answers just so you can check your answer. See my position. It's another pi. Look at that. We go to 5. Okay, so my derivative is positive and then negative. My position increases, then decreases. Pi is going to be my winner. My position at pi is equal to -2, which is where I end at time 5. And then I'm going to subtract this displacement from pi to 5, going from left to right, pi to 5. I have that my displacement is -5. I decrease 5.5 to get to the position of -2. Well, I must have come from 3.518. This is the max position at this time. Your justification would be that your derivative is positive from 0 to pi, and then your derivative is negative from pi to 5. That is just showing you that you understand that your derivative is positive, your position's increasing, your derivative is negative, your position decreases. You must have a max there. You don't have to say more than that. And then this one, it's just so much quicker, guys. It's so much quicker with decimals. Everything is so much quicker and so much easier to like investigate and be like okay with. Oh, look at that. That's great. Great question. Great question. Great question. So much easier to investigate. Guess what? This is going to be a very large negative number. I don't know how very large it is, but it's going to be a negative number. Yeah, right? Why do I know that? Because this is my derivative, and my derivative is negative. This is an easy question. My derivative is negative from 0 to 3. Therefore, my position is going to decrease. My position starts at -4. My position decreases that much. My position is at my highest point right there. I know that's my winner. P of 0 equals -4 is the max position because my derivative is negative from 0 to 3. Winner, that's it. If you want to find your position at times 3, because I ask you to, you do -4 and you got to add that negative value. So you get a bigger negative value, and this makes sense. Cool. Okay. You have all of the things you need to find the positions at the times, not at every time, but at the times that are your candidates. You have 0 times 0 times 3 times 5 times 6. These are your times when you have candidates. You know your position increases, then decreases, then increases. So this is a possible max, this is a possible min. This is a possible min, this is a possible max. But like it's easy to check. Your position at 0 is 2. We can see we increase 5. You need to actually show your work in the future, but let's just get to the next question. We're going to decrease 3 to get to my position at time 5. So when I decrease 3, my position at time 5 is 4. And then my position at time 6 is 5. So what's the winner? This is the furthest left. That is my min position. And then this is the furthest right. This is my max position. Cool. Y-axis, no big deal. Whatever. It's still the derivative of my position is negative, then positive, then negative. I don't have the ability to find all of my positions, but I do know my position decreases until t equals 1. My position increases until t equals 3. My position decreases until t equals 4. So we decrease 2, we increase 6, we decrease 3. I ended, in the middle. My position at time 3 on the y-axis was 4. So therefore my position at time 4 is 1. If I end up at 4 and I increase to get to 4, I have to subtract that 6 to get my position at time 1 is -2. If I decrease 2 to get to -2, I must have started at 0. That's cool. Make sure it all makes sense. 0 minus 2 plus 6 gets me to a position of 4 minus 3. So that's cool. So this is my furthest left. Actually, it's my not furthest left, but it's like lowest. It's my min. And this is my highest. That's my max. But we'll say lowest and highest on the y-axis because you're going up and down. Okay. Oh, look. It's a free response question from 2004. It's fun to see like what this is going to look like. What is your test going to look like? Your test is going to look like this. Just like here's essentially a derivative. And here's a bunch of questions about motion. Whether you can take the antiderivative or you have to use your calculator. It's a calculator question. First thing I'm doing is saying my derivative of my position is velocity. Next thing I'm doing is that my position at time 0 is -1. A lot of students will mess this up, but P of 0 is -1. And I'll say that's my position. My acceleration. Okay, so that's my derivative of my derivative. So that's P double prime at 2. I'm going to want to take the derivative of V. Now, I don't think I've taught you this yet. We have to take the derivative, find how your meters per second are changing per second. You will take the derivative of V at 2. You could say it's V prime of 2. We're going to have to go over this. We have V, right? Let's graph V. You also do tan inverse. I think if you do tan inverse, you get the same thing. You have to go to the -1 and it recognizes it as, yeah, okay, good. So that's good to know. If you do tan to the negative first, it recognizes it not as not as a reciprocal function, but as an inverse function. Okay, so cool. We got this 0. That's important. Probably going to save that. So easy. And we need to take the derivative. Ready? D comma dt of v of t when t equals 2. Does that work? Is that how you take a derivative? I've never taken a derivative. Yeah, I think that's it. Like, what happens if I get rid of that? Then it won't give me a thing. But if I add that, I said, what's the derivative of v of t when t is 2? We could check this. Let's copy that. Y minus v of 2 equals that value x minus 2. Is that the equation of the tangent line? Yeah. Yeah, it is. So it's like, good. All right, now we know how to take derivatives. All right, cool. So negative 0.132. What does that mean? This is new to you guys. You don't know how to do this. We haven't done this, so whatever. What does that mean? Okay, well, if the second derivative is negative, the first derivative is decreasing. Cool. You can see how your velocity is negative and decreasing, which means your velocity values are getting further away. So that means your speed is increasing. What? What do you mean my speed is increasing? Yes, my speed is increasing because my velocity and my acceleration have the same sign. If you want to be more specific, you can say velocity is negative and decreasing at t equals 2. Your velocity is negative and getting more negative. But it's honestly easiest to say just like v and a have the same sign, which means your velocity is getting further away from 0. All right, highest point, justify your answer. Well, my derivative is positive until a, and then it's negative after a. Get rid of this, get rid of this. Okay, and we're going from 0 to what? Or are we just talking about in general? Yeah, so it's forever, but it's an easy answer. It's gonna be at a. A equals 0.44302. Do you ask me what the position is? No. I mean, it's a little soft, this question. I would say, what is the time and position when it's at the highest point? But like, this is my answer because P prime is positive from 0 to A, and then P prime is negative from A to infinity. But you're better than this. Can we please find the position? Yep. Position of A is the starting position plus the accumulation of my derivative, my total amount that I increased, which is the accumulation by meters per second times seconds. So I'm going to integrate / accumulate V from 0 to A, and I just increased that much. So it's not much. but it is something, negative 0.953. Oh, find the position of the particle at time 2. That's easy. Position of 2 is equal to negative 1 plus the displacement. Well, it's like, let's not do so much analysis. Let's just find the answer. I'm going to decrease even more, I can tell. Like, I get to negative 1.360. This is my position. My position is negative, which means I'm left of the origin. Cool. Since my position is left of the origin, and since my velocity at time 2 is negative, my position is negative, and since my velocity is negative, my position is decreasing. If your velocity is negative, your position is decreasing. So I'm going from negative 1.3 to negative 2 to negative 3. So since my position is left and my velocity is headed left, we are going away. What's your justification? Based on positions and velocities, okay? There you go. Stayed after school for this because it's a beautiful day. It's really nice. And I was just helping students earlier. I don't mind. I was going to work out, but it's okay. Work out tomorrow. We're fine. Eat a healthy dinner. It'll be good. Keep it up. Hope you get it. Last lesson, next class. It's a fun lesson. We're going to go back to Big F. And we're going to get ready for free response problems on your test. We actually have like 2 days of review. Because part of Friday's lesson is like starting to prepare for the test. You'll see. Peace.